Hello, and welcome to Based on Facts, where fiction and superstition meet logic and scientific facts, on WELT 95.7 FM, broadcasting from the Allen County Public Library. My name is Chris Rex, and today we're going to be talking about, were dogs designed by aliens? Okay, and I guess when I say aliens, I should go aliens, just to give credit to the ancient aliens professor that I love, whose name starts with a P. I can never pronounce it. It's like Palaskos or something terrible. I have no idea. But anyway, dude with crazy hair, one of the main hosts and founders of that show. Very entertaining, not terribly scientific of a show. But I came up with the idea for this episode just because I was a guest, very graciously, the previous show that's on before this one, Advanced Archaeology Review. They invited me to come on and kind of ask the author that they were talking to some questions, maybe probe his mind a little bit, because this particular author that they were talking to was one of these pro-alien types of people. Basically saying that aliens have had a significant influence on human history as well as the genetic history of a number of different animals on this planet. So I'm kind of going off of a topic that we briefly discussed on that show a couple weeks ago, and trying to explore this topic on my own, because it was very frustrating for me, being a biologist, to sit here and have people who have no biology training, who have no biology experience, who have no biology education, and to have them try to tell me how biology works. I always find a lot of issue with that, because I don't try to go up to a mechanic, to a car mechanic, like here in town at Tuffy's or something. I don't try to go up to them and tell them how to do their job. I don't know the first thing about cars, okay? I know that I put gas in it and it goes. Kind of have to maintain oil levels and maybe some windshield washer fluid, but other than that, really, if I have any problems beyond that, I take it to a shop, and they know more than I do. I realize that we have experts in society that we go to deal with our problems or to solve certain societal problems, which is what scientists do, okay? And biologists in particular, they're trying to look at a number of different things to not only improve the human condition, but improve the condition of the planet around us. And that's why I love that. That's part of my passion when it comes to the field of biology. So when I'm sitting here and I'm being faced with these people that have very, very strong opinions and very strong emotions regarding biological topics, but they have absolutely no data, no education, no experience to back any of it up, it's frustrating to me that they don't listen to what I'm saying. Because I'm sorry, I listen to what car mechanics say. Now, granted, you do have the exceptions, of course, but generally speaking, I listen to what they say. If I'm going to the dentist, I listen to the dentist with regards to my teeth, because he knows a lot more than I do. Or actually, in my case, it was she. She knows a lot more than I do, okay? And I admit that. I'm okay with that, because nobody knows everything. But to sit here and assert that you know more than an expert, that takes some real guts. And more often than not, by guts I really mean stupidity. I hate to say it that way, but honestly, if you're going to sit here and try to tell somebody how to do their job, you're either incredibly bold or you're incredibly stupid. One or the other. Okay? So, there's a certain degree of healthy skepticism, and then there is unhealthy skepticism. And that's what I see in way too many people nowadays. Okay? It's this unhealthy skepticism, which is to say, let's doubt everything. Let's call into question everybody at all times, regardless. Just because I really think that fundamentally my thoughts are equal to your thoughts. That's not the case. Okay, some thoughts are better than others. All right? Absolutely. You can't sit here and say that, my thoughts on working on a car and how to fix it are equivalent to a mechanic's. I don't know the first thing about a car. I listen to the mechanic. Even when I'm flying a plane out to Colorado or something, I don't tell the pilot how to do their job. I don't know anything about flying a plane. Who am I to say that? I see the same thing around this time of year with people watching sports, right? It's getting football season now. My wife is obsessed. Every, Sunday or whatever? She is obsessed with watching football. So sure enough, being a football watcher, you're on the couch and you insist on trying to be an armchair quarterback, right? Where you're trying to give advice to the players. Even though the point of view that you have is a lot better than the view that they have. Okay? Just think about it from a literal perspective. Okay? They're in a helmet, which means they have tunnel vision, about like that. Alright? If you try to think about that from a global perspective, it's very, very difficult to see everything on the football field when your point of view is this. And in this view, you're focused on the people that are about to tackle you. Being the quarterback. You're focused on the people that are about to tackle you, and you're trying to focus on all the different people on all different parts of the field that may or may not be open for that pass. Okay? So to sit here and be like, well, come on, quarterback, you should have known that there was this dude way over here, and that he was clearly open. Like, quarterback may not have seen it, man. His focus might have been on that dude that's blitzing him at the moment, and he's like, you know what, screw it, I'm not going to get sacked, I'm just going to toss it. Just going to toss it right in the, right out of bounds right over there, just so that I don't lose yardage, and we'll call it a good day. I lost this round. Whatever. Next down. So it's frustrating to me to see that behavior, but it's sports, it's more understandable. It's supposed to be emotional, right? So I don't get too bent out of shape about it. It's just when people literally sit there and go on a tirade about how much better they can do at that job, that's when I start to really get aggravated. When people sit here and look at somebody, big and famous who just retired, Peyton Manning, they're like, well, heck, I could have thrown better at that game. It's like, okay, well then, why don't you apply for the big leagues then, Tiger? If you're so great, why don't you go ahead and do it? Otherwise, shut your mouth and understand that that guy's pretty good. Okay? May not be the best, but he's pretty good at what he does. Otherwise, he wouldn't have gotten all these different accomplishments along the way. And so the same thing with my situation, with educators and with scientists. It's like I would not have made it to this point in life to have my master's in biology and not know at least something about biology. Okay? Not to say that I'm a complete expert, even though I am a complete expert. No degree of, overbearing ego there. But it definitely implies that I've gone through a number of different trials. Okay? Umpteen credit hours worth of biology classes. Okay? I think I calculated it once. It was like 60 credit hours of biology classes or something ridiculous. I don't even know. I'd have to look at the number again. But a whole lot of biology, okay, in my life. And so to have somebody who hasn't taken even a remote college course on biology try to tell me about biology, it's infuriating to no end. Absolutely infuriating. So that's where we are with this episode, okay? I was kind of peeved, trying to talk to people about aliens and archaeology, and then we got on the topic of dogs. Okay, and one of their assertions was that, well, dogs have so much difference from wolves that they had to have been designed by aliens for us as companions. That there was no way that dogs could have evolved on their own. But if you go up to somebody on the street, they're going to tell you something along the lines of what I just said. As far as what I said initially here, they're going to say that dogs are the product of artificial selection by humans, not by aliens. Okay? And the average person knows this and realizes this. But some of these alien extremists over here that assert a completely different story. The fact that there are a lot of differences, morphologically speaking, between dogs and wolves, and that may not necessarily be a result of artificial selection. So where is the data for that? Like, where's the evidence supporting that humans have done this procedure with dogs, domesticating them from wolves, as opposed to aliens just like modifying some genes and then like dropping off a perfectly formed dog onto our planet to help us hunt and gather and do whatever things ancient humans were doing. So we're going to kind of analyze that in this episode and kind of go in that direction and just kind of explore what the data says out there and where the conclusions end up driving us towards. So we could start with how domestic dogs, Canis familiaris is the species name for the domestic dog. These animals are thought to have been domesticated from gray wolves, Canis lupus, about 15,000 years ago. Okay. Now this is kind of an average roundabout number. We have a number of different studies exploring this topic. We see around 15,000 years is probably a good round estimate for about the time frame that dogs really started becoming domesticated and prevalent in human populations. But if we start looking at the fossil record and start exploring some of the genetic evidence a little bit, we start seeing that there's a little bit of evidence to support that dogs may have started being domesticated about twice that number of years ago. Okay, so about 30,000 years ago, humans may have started domesticating dogs unsuccessfully. Okay, we have a few skull remains and such that indicate some dog-like traits, even though they are still wolf, specifically when it comes to DNA. So it seems that there have been a number of different attempts throughout human history to domesticate the dog. Now, the cool part is that as far as actual archaeological evidence, we have discovered burial sites of humans that included dogs or dog hair. And we found those sites as many as 14,000 years ago. Okay. So once again, that lines up pretty good with our initial estimate of about 15,000 years ago. So that's pretty cool, learning that humans and dogs have been laid to rest in the same grave because it was owner and pet. Okay, that's pretty cool, pretty awesome to take a look at there. Now, what's interesting is that once we start to try to piece apart this whole puzzle that is the difference between dogs and wolves, we see that there have been at least 3 different species branching from a single ancestral point. Okay, so at some point in the past, there was an ancient ancestor that resulted in modern dogs, resulted in modern wolves, and happened to result in ancient wolves. Okay. Now, that's kind of our first thoughts on how this whole thing laid out, was that everything branched from one point. Then come later on, we started really looking at DNA a little bit more specifically, And we started figuring out, oh, well, okay, it wasn't a single branching point that resulted in these three groups. Okay, let's just do that. In these three groups, we actually have a single branching point into two groups, and that second group was actually ancient wolves that also spawned off the common dog that we know today. Those ancient wolves are no longer around. Okay, that's kind of why we call them ancient wolves, because they did become extinct at some point in the past couple of 10,000 years. As such, that tells us that the modern wolf, the modern gray wolf, is not the direct ancestor of the dogs that we see today. Okay, so as much as people might want that to be the case, that is not the case. And that the actual ancestor of every dog on this planet comes from an ancient wolf that became extinct. So, kind of neat little tidbit there to kind of focus on. Now, the interesting part about studying the first steps of domestication in the dog is realizing that it's a bit more complex than we thought. Okay, classically speaking, we think of this artificial selection scenario where humans go out into the wild, they find some wolf pups, they bring them back to the village, they raise them as their own, and they do this for several generations, trying to select for the best pups that are least aggressive, most attentive to man, and raise those up and basically discard or kill the rest. We can imagine that scenario. Okay. The issue is that there's increasing support against that scenario. Okay. That scenario seems to have occurred later on, after dogs had already domesticated to some degree. Now, at first that seems counterintuitive. You're like, well, what? How can dogs evolve without us breeding them? Like, that doesn't make any sense. And then you start thinking about it and you're like, well, okay, at that point in time, 15,000 years ago, humans were predominantly nomadic. Okay, we basically went from area to area, hunting game, gathering berries, things of that nature, and we were just moving from place to place. Okay, just kind of following the herds or following the resources in some way. Dogs appear to have evolved on their own to some degree, because it appears that the wolves that were most tolerant of human presence started hanging around the humans and following them on their nomadic pace between herds of game or bunches of berries or whatever. Okay, these dogs were essentially the first few wolves that came out and were okay with being near humans. Okay, we're okay with picking up after the scraps of humans. You know, because humans, as much as we like to think that we're efficient, we're really pretty grossly inefficient. Okay, and for those of you who have dogs at home, some of you may even, you know, eat a steak one night for dinner and then toss the leftover bone material to your dog. Okay, now I don't do that because I've seen too many cases where dogs have been injured by bones or by swallowing chunks of bone, and then it causes a bloody stool. So I don't do that personally, but what I have seen is dogs be able to eat an entire bone. Humans, not so much. Okay, we're not really designed to be able to do that very well. But dogs can do that, and dogs can get at that nutritional bone marrow that's beneath the compact bone. In the spongy bone, you have a lot of nutrition in there because that's where all the blood cells are made. Okay, all the white blood cells, all the red blood cells. So all that nutritional stuff is in there, and that's great to get at if you're a dog. So we see a scenario where we have these scavengers that are okay with being somewhat close to humans, because otherwise humans are larger than a dog. Okay, let's say even a good sized gray wolf is probably, what, 70 pounds, I want to say. A human is twice that. Okay, so the wolf is going to be more afraid of the human and want to stay away from the human. Now, obviously, there are cases where if there's a lone human and a pack of wolves, then the human becomes the prey. But generally speaking, if we're talking about an encampment, a nomadic encampment of people, wolves are not going to come anywhere near that. Okay, they realize that there is a whole lot of people, a whole lot of big creatures in one location. They're not going to come in that tight formation and risk anything. Especially since humans at that time were using fire, and fire tended to be pretty good at keeping away animals at night. But, like I said, there were those few wolves that were actually okay with coming closer to humans, coming closer to the fire at night, and coming in to get those scraps. Alright? And we're seeing the same type of evolutionary scenario right now. If you go to a state park, for instance, I bet you'll be hard-pressed to find a state park in the continental U.S. where you do not have raccoons that come into the campsite and steal your crap. Alright? Because raccoons are bold little things. Alright? They are incredibly intelligent, incredibly agile, incredibly silent when they want to be, and perfectly camouflaged for coming in the dead of night and stealing your stuff, whether it be garbage, whether it be a bag of marshmallows, which they apparently love like nothing else. They are incredibly good at coming in to a human encampment and stealing whatever they can scavenge. So we can imagine a similar scenario many thousands of years ago where dogs were wolves that became dogs started doing this. Okay, so that kind of started this process of domestication. You have wolves coming in, starting to be more okay with humans being around. That starts that process of domestication. That leads to a different line of dogs, so to speak. Once that line was formed, and this line might have been formed, maybe around the time that we found some of these first skulls and such, maybe about 30,000 years ago, this started going on. From that point, we can see, now humans are starting to go in there to these dogs that are already close to camp, starting to go in there and take these dogs, these wolves really, these tame wolves, and breed them themselves, and starting to fit those dogs towards the human purposes, whether it be hunting, whether it be protection, protecting a herd of goats or something, or sheep, or whether it be protecting the camp at night, even from other human attacks, right? Because we still had a lot of warfare between tribes at that point as well. So these dogs are being integrated into human society to where they start joining the nomadic group as they go around from herd to herd or whatever. So that's kind of cool. Trying to think of the whole scenario like that. And once again, we can kind of track that not only through the fossil record, but through DNA to some degree. And we'll talk more about that later. Now, the other thing to keep in mind is that since these dogs were descended from wolves originally, we see a number of instances where they're still interbreeding between wolves and dogs. Okay, whether it be just pets that were discarded and allowed to go back into the wild after their owner died, or whether they escaped, or whatever happened, we still see a great degree of interbreeding between domestic dogs and the wolves. Now, that kind of fudges some of the genetic data that we have. Okay, it kind of muddles the picture, so to speak. And we'll talk a little bit more about that here in a bit as well. Just generally speaking, we can start looking at some of the studies. that looked at the DNA, whether it be nuclear DNA, which is inside the nucleus of every cell of your body, with the exception of red blood cells and maybe a few other cells. But generally speaking, nuclear DNA is in most of your body. And then we have mitochondrial DNA, which kind of talks about this little organelle. If you remember your cell biology, organelles are these cute little mini organs inside your cell that perform different functions. Okay, like the nucleus is an organelle, it contains the DNA, right? We can talk about the Golgi complex, which packages and transports a lot of different materials in your cell. We can talk about the endoplasmic reticulum, which kind of does some similar functions to the Golgi. Talk about lysosomes, peroxisomes, a number of different organelles there in the cell. But the one that I love talking about is the energy producing one. Okay, this one produces all the energy, most of the energy for organisms that actually use oxygen to produce energy. Okay, so every single aerobic metabolism utilizing organism will use this particular organelle and need it to function, and that's the mitochondria. The cool thing about the mitochondria is that it has its own DNA. So that kind of leads us to believe that the mitochondria itself, the mitochondrion itself, was actually a prokaryotic organism, like a bacteria, very, very simple organism with no organelles. It was a little mitochondrion that actually became just kind of taken up by the cell, by the eukaryotic cell, and became integrated with all the other organelles in the cell already. The advantage is that it's kind of a symbiotic relationship to where mitochondrion gets to get energy from the eukaryotic cell in the form of glucose, and then the mitochondrion produces a lot of ATP for energy use in every other part of the cell. Okay, and using the mitochondrion to produce energy is a lot more efficient because it relies on oxygen. If you don't have oxygen, you have to rely on anaerobic metabolism, which is about 5% as efficient at producing energy. Okay, so we can get about 20 times the energy from a mitochondrion than we can without it, which is why your body is so good at using energy. We are incredibly wasteful organisms just in the natural world around us, but inherently we are incredibly inefficient. Okay, we are constantly using vast amounts of energy. Humans are expensive, very, very expensive creatures, and it's because we have these mitochondria that are able to produce all this massive amounts of energy from a single glucose molecule. So that's great for us. Not so great when it comes to gaining weight and trying to lose it again. That becomes a much more complex scenario. But anyway, I digress. So mitochondria have their own DNA, and what's cool about mitochondria is that you only get mitochondria from your mother. Okay, so it kind of comes down to how sperm are formed, how eggs are formed in mammals. Eggs basically have every single component of a cell, whereas sperm are stripped down cells. They are literally just a compact version of a nucleus. That's it. Every other part of the cell has been stripped away, including the mitochondria. Okay. So when it comes to the sperm entering an egg, you only have the nuclear DNA entering the egg. You don't have any mitochondrial DNA entering the egg. As such, you only get your mitochondrial DNA from your mother. It's simply passed down through generations on its own mutation rate, and we can track that very, very, very accurately in most cases. Okay, because there's no intermixing like there is nuclear DNA. You know, in your nuclear DNA, we have half your DNA coming from your mom, half your DNA coming from your dad. Creates a mutt of the two. That becomes really, really difficult to track, genetically speaking, even with the advanced techniques that we have today. There's no way to accurately track that sometimes, just because there's so much intermixing going on. Anyway, we can look at mitochondrial DNA, And this one study collected DNA from 140 different dogs of 67 different breeds, 162 wolves, and 162 wolves from 3 different continents. Okay, so we tried to get a good coverage of dogs and wolves and take into account some differences in location. And what was cool about this study was that they actually found that there was about a 1% difference between dogs and wolves, okay, genetically speaking, when it comes to mitochondrial DNA. And based on that measurement, that says they may have diverged as early as 135,000 years ago. Now, a number of people don't agree with that number so much. They think it's a bit high. I think I agree that's a little bit high. Some people believe that mitochondrial DNA, because it does have a very fast mutation rate, about 20 times the mutation rate that nuclear DNA does, they believe that maybe it was this constant breeding and artificial selection that kind of exacerbated that degree of mutation. So that may not necessarily be the greatest number to use, but we have a number, okay? And that's based on that 1% difference genetically. Now, when we look at coyotes, okay, or coyotes, we see that they're about 6% different from wolves. Okay, so coyotes are a lot more different from wolves than dogs are, by an order of about 6. So just kind of interesting. But once we try to create a phylogenetic tree of dogs and see where their different phylogenies came from, we see that there appears to be about 4 points. Okay, 4 different branches for dogs along the way. And that's kind of cool. You know, we have some that appear to be distinctly American. We have some that appear to be distinctly Asian. And we have some that appear to be distinctly European. So we're trying to figure out where dogs came from. And we're starting to get this picture, well, maybe dogs were domesticated a couple different times. So we're starting to get this idea in our head that, well, maybe it wasn't just one ancestral population from the ancient wolf. Maybe there were multiple populations that were domesticated all over the world. So we're starting to get this in our head, and we're like, huh, well, that's kind of weird. So let's explore this a little further. Another study looked at genetic DNA this time, collected from 28 different breeds of dog that are officially recognized by the American Kennel Club. And they collected a lot of dogs per breed, okay, about 40 dogs per breed to analyze, just to really try to get a solid grasp of the amount of variation going on here. And they saw that Australian Shepherds, okay, which is about the closest relative to what my wife and I have as a pet, they formed a group all on their own, okay. And so that gets us thinking, well, maybe that's because it was kind of geographically isolated, right? So these dogs were taken into Australia and used for cattle herding or some other flock herding animal, okay? And maybe that's why they kind of have an off group here. They saw another out group that consisted of some East Asia kinds of dog breeds. Those like the Chow and the Akita, which are thought to be highly related, as the Akita was actually evolved from the Chow. So those form another outgroup. Other than that, all the other dogs fell into a single group. So now we're seeing a situation with the genetic DNA that we're down to 3 different lineages. Okay, Australia, Asia, and basically Europe and everything else. So okay, that's kind of interesting. Kind of narrowing it down here. There was another study that looked at genetic DNA, and in this case they had 10 different animals from each breed, and they did 80 different breeds of dog, and then they looked at 83 different types of wild canid types, okay, whether we're talking about wolves or foxes, coyotes, whatever. So 80 dogs, 83 wild canids, and they tried to look at 57 different morphological traits between all of them. Okay, whether it be size of the teeth, the number of the teeth, shape of the jaw, size of the paws, the legs, the body, the weight, even so far as the ears, okay, whether the ears are pointed or whether they're floppy. Okay, and I always kind of make fun of our dog, Kita, because she has one ear that's pointed and the other ear that's kind of floppy. Very strange looking dog. But anyway, they looked at all these different types of traits, and they tried to see if there were any trends among all these animals. And what they saw genetically among all these traits was that there was a significant population bottleneck at some point in the past. Now, by bottleneck, we mean that the population at some point in the past became very, very small, okay, which had limited the genetic variability it had from that point forward, because basically from that point forward, they were all inbred. Okay, and we see the same thing with, like British royalty, for instance. You see that inbreeding negatively impacting the genetic variability of those people, making it more likely for them to have rare genetic diseases and other, bad conditions that are genetic. Makes you more likely if you have inbreeding. So that's kind of cool. We see a bottleneck here with the dogs that's not present in the wild canids. Okay, so all the domestic dogs have some sort of bottleneck in their past, which tells us that there were only a few dogs that started all domestic dogs. Okay. So, okay, you'll see maybe you'll see the alien conspiracy theorists be like, aha, we found it. That's it. There were only a few dogs in the start because there were only a few dogs that the aliens beamed down after altering their genetics for us. No, that's factual, that there's a population bottleneck, but that does not necessarily mean aliens. Okay, that is not a default response. That is not a response supported by any level of scientific evidence whatsoever. And so we can go on from here and say that there was a study just this year looking at trying to determine where these different points were initially. Whether there were 4 different points of initial domestication, 3 different points of initial domestication, or as this study found, 2 initial points of domestication. Okay, so we're kind of seeing a narrowing down here as we're starting to get at what actually happened in the past when it comes to domesticating dogs. And so the study just published earlier this year indicates that there are actually 2 lines. We have a line of dogs from East Asia, and then we have a line of dogs from Western Eurasia. Okay, so Europe and maybe the Middle East kind of region. So those are the 2 different points that we have right now for being the origin of all dogs today, are those 2 points. And then some people are going a step further and saying, well, it may appear as though there are 2 points, but maybe in actuality, both points really converge onto one point or the other. And it seems like some people are kind of hinting that maybe East Asia is where dogs actually originated from. And then they were subsequently brought to Europe from that point. But we're still staying tuned on that. Okay, we still don't quite know or understand what all happened when it came to dogs and their process of domestication there. But the other cool part of this study that was just published this year, they just to give you a little idea of what they did, they looked at the genetic sequences from 59 different ancient dogs, looked at how they compared to a dog 5,000 years ago. Okay, so relatively recent. Nobody debates the validity of that dog. And they indicated that, genetically speaking, there appears to be a split between these ancient dogs around 14,000 years ago. And funny enough, from wolves. And funny enough, that coincides with the appearance of dogs in a number of these different regions. Now, obviously, some of these regions didn't have dogs until much more recently. In fact, 6,500 years ago seems to be the most recent time point that any of these areas ended up getting dogs. But yeah, in that time span, that about 7,000 year time span, dogs were everywhere. And the genetic evidence correlates with the fossil evidence, which correlates with the mitochondrial DNA evidence. All of these different types of evidences conclude the same thing. Okay. All of them done by independent researchers, independent locations, independent labs, independent countries, independent organizations that they're part of. Okay. So it's not like this international consortium of dog genetics that's like conspiring to keep the truth hidden or something. These are all just people that are trying to seek the truth. Okay, but being scientists, they're really trying to support all of their hypotheses and try to disprove everyone else's. Okay, scientists don't like to agree. Scientists like to be the person who discovers something and proves everyone else wrong. That's what scientists do. Okay, we're all jerks, right? So with us all being jerks, we just want to go around proving everyone else wrong. It's kind of hard to do that when we're all giving the same bit of data to indicate the same years that dogs diverged from wolves, which is about 15,000 years ago. And everybody's coming up with the same numbers. Now, like I said, there were some earlier instances where there may have been attempts at domestication that failed for one reason or another. The other cool part about this study is that looking at the nuclear DNA, they started to see that the modern dog is actually more related to the Siberian Husky. And that seems to be probably the closest ancestor that we have to one of the original dogs. Okay, so we're thinking that the originally, some of these wolves that were following the human encampments and domesticating themselves, so to speak, that dog may have evolved to be more like a Siberian Husky at that first bit of domestication. So, just to give you an image there, that way you're not just picturing some weird, crazy looking wolf. Siberian Husky, that gives you a pretty good visual. So, I think that's pretty cool. Now, if we really look at how dogs differ from wolves genetically, we can see that, like I said before, they share about 98 to 99% of their DNA with wolves. Okay, not much difference at all. Now, once again, coyotes share about 94% of their DNA with wolves compared to dogs. But yeah, that's pretty similar. 98, 99%, pretty similar. And so with that, it kind of surprises us because we're like, well, then how are they so different? That's crazy. And so we see those differences, that 1 to 2% of difference is really localized primarily to 11 different genes. And these genes have experienced increased mutation rate as a result of that artificial selection. Okay. Now, these genes, once we look at their function, we see that they have a variety of functions. Okay, and some of them we'll talk about a little bit later here, but the one that I do want to mention right now is that there was a gene or two that was associated with the fight or flight response. Okay, basically looking at how adrenaline works in the common dog. And what we see is that it's changed in a way that kind of tames the dog down. Because if you have a lot of adrenaline through you, you're feeling very nervous, very scared, maybe even aggressive to some degree. And with modern dogs kind of calming that gene down, they have become very tame, very passive when compared to their wolf ancestors. And that's awesome that we can look in the DNA and see that change and track it over time. The other thing that we kind of noticed is that we can calculate an average background mutation rate. And from there we can kind of back calculate how old some of these lineages are. Okay. And if you think about how huge genomes are, I mean, genomes can be huge. If we look at the size of the dog genome, they have about 39 different chromosome pairs, okay, compared to our 23. Okay, so almost twice the number of chromosomes that we have. But they have fewer nucleotides. Okay, so more chromosomes, but fewer nucleotides. So they just package up fewer nucleotides per chromosome, essentially. And they end up having about 2.4 billion nucleotides in their DNA, whereas we have about 3.2 billion in our DNA. So we're about 50% larger genetically speaking than dogs are. That doesn't necessarily mean that we're better by any means, but does mean that we are different, so to speak. But if you use that background mutation rate that we calculate by looking at the nuclear DNA, you see that dogs end up differing or end up changing their DNA by about 1.2 million nucleotides every 3 years, which is phenomenal. And that is because of artificial selection. That is the kind of driving force that we're doing on dogs, okay? So when you try to think of dogs and you're like, oh, well, 11 genes, that's not much, whatever. It's not much of a difference between dogs and wolves. Well, but every 3 years you can change the DNA by 1.2 million nucleotides. That is a huge amount of DNA change. Okay, you're talking about, what is that, 0.05% of the DNA being changed in 3 years. That is huge, and that's because we are artificially selecting for different dogs and breeding them differently. So, pretty incredible. Trying to put this all in perspective for you, dogs are 98 to 99% similar to wolves. Nobody debates, with the exception of the alien people, nobody debates that dogs and wolves are similar, and in fact share a common ancestor. And yet, when we look at humans, we see that humans and chimps share about 98 to 99% of our DNA. And yet everybody gripes about that. Okay. Somehow a wolf compared to a chihuahua is okay. We understand they have the same ancestor. And yet comparing a chimpanzee to a human, then we start to lose our minds. Even though I think personally there's more differences between a chihuahua and a wolf than there is between a chimpanzee and a human. Maybe that's just my opinion. I don't know. Anyway, just something that kind of blows my mind there. The other thing that we can kind of look at is when you look at how much variation there is within each of these dog breeds. Okay, you really don't see much variation within the breed. Okay, they're about 95% similar genetically within the breed. Okay, they're pretty inbred. Nobody's going to lie about that. However, you look at the differences between the dogs, okay, in these different breeds. And there's a study that looked at 85 different dog breeds, and they saw that the DNA differed between each of those breeds at about 28%. Okay, so about a quarter to a third of all the DNA differed between dog breeds. Saying there's some pretty good selection going on there. If you look at humans, it's only about 5%. Okay? That's why race is really kind of it's kind of an unfounded thing. There's not a whole lot of evidence to support it when it comes to considering human races to be distinct groups. Okay? They're distinct groups, but they're not very significantly distinct. Okay? Which is to say that there's no genes that are unique among any group, nor are there more genetic differences between groups than there is within a group. Okay? So basically, let's say we take all of Africa, all the Africans in Africa, and we look at their DNA. We will find more differences between Africans than there are differences between Africans and Europeans. That's kind of crazy to think about. There are more differences within each racial group than there are between them. Dogs are the opposite. There are more differences between the dog breeds than there are within the dog breeds. Completely opposite scenarios. It's kind of cool to look at. Compare those two. And even within dogs, if we look at the amount of variation between the dog breeds, there's more variation going on there than there is between domestic livestock. Okay, whether you're talking about this kind of cow or that kind of cow, Angus versus I don't even know what all the different kinds are right now. But you have your different kinds of cows for different purposes, right? We have like milk cows and we have meat cows. Differences between those guys is pretty small compared to the differences between a Chihuahua and a Great Dane. That difference is huge. Difference between a meat cow and a milk cow, very small compared to that. So just to show you how much we've selected for these different traits in dogs, it's absolutely mind-blowing. If we're looking at the ways that a wolf differs from a dog, we can see different effects of domestication. Okay, we can see 15% smaller brain size in dogs, just because they were domesticated. We've seen this in other domesticated animals. You can talk about how wolves, if they're raised by humans, they'll be fine. They'll kind of act like dog pups right up until about 8 weeks of age. At that point, they start not caring about humans and becoming maybe even a little hostile towards humans. Okay, they won't look them in the eye. They don't necessarily know what a human is pointing at or what they're trying to mean. And that's just not the case in dogs. Okay, dogs and elephants are the only other animals on this planet, from my research. Okay, only other animals on this planet that can understand a human and what they're pointing at. Elephants seem to be very good at this innately. Okay, now this is thought to be because their trunks, they kind of use it to maybe not necessarily point, but they do use it in very directional fashion. But elephants are very good at it, and dogs have a great predisposition to learning this behavior. It's not to say that all dogs are experts at learning pointing. Okay. It's one thing that kind of bothers me. I see these people posting online, well, my dog doesn't know what a pointing action is. That's not the point of this. Okay, the point is that dogs are predisposed to learn that. Okay, they learn it very easily, typically. Not in all cases. Okay, I very rarely use all or none in my wordage because that's how science works. We are very, very rarely all or none. The tendency, the average, says that on average a dog will learn pointing. On average a wolf will not. That's the average. That's not to say that there isn't one wolf out there that can learn what a pointing move is. That's not going to disqualify the argument. The argument is done from a scientific perspective, including averages among individuals. It frustrates me when somebody tries to pick apart an argument like that. Let me see, what else was I trying to say? Oh, okay. 1 second. The other interesting thing is that when we look at differences between wolves and dogs, we see that dogs have 5 different pads on their feet. Wolves have about 3. Wolves also have larger pads on their feet. If we look at the skull of a wolf, we'll see that's very long, kind of flat. It has this very slow taper along the nose. Okay. Whereas if you look at the dog, you'll see that obviously it's going to be a little smaller of a skull. It'll be a little shorter of a nose, so to speak. It'll be more of a domed skull, and it'll come in contact with the nose at a very sharp angle, so it kind of looks like a little kink, so to speak. Wolves have a lot of teeth, and their canines are kind of angular in shape, very barbaric, so to speak, medieval almost. Whereas dogs, they tend to have fewer teeth and these kind of smaller, a little more rounded canines. Okay, a little less intimidating, so to speak. Now, dogs also have different reproductive strategies. All right, they reproduce twice as fast as they get into heat twice a year versus wolves who only do it once a year. Okay, they also do it at about half the age. They reach sexual maturity at about half the age, about 9 months to a year, compared to wolves, which take about 2 years. Wolves are monogamous, dogs are not. Another thing, when it comes to vocalizing, dogs tend to bark, wolves tend to howl. But wolves tend to howl to increase pair bonding within the group, within the pack. Dogs tend to bark to alert people, to get their attention. They don't really tend to do anything with bonding directly per se. If we look at an example where we try to take a wild dog, wild kind of canid, and domesticate it, we can start seeing some of these changes fairly quickly, which is kind of incredible. So there are these Russian scientists that took these silver foxes out of the wilds of Siberia and started breeding them, artificially selecting them and breeding them to see how long it would take to domesticate the silver fox. What they saw was within 3 years, they were able to start breeding out aggression. Just within 3 years. That's incredible. Go 8 generations down the line, and they've already started becoming more like dogs. They're incredibly tame around people. They start actually showing affection towards people. They start becoming playful with people. They start paying attention to humans and actually not just tolerating their presence, but enjoying their presence. 8 generations. That is no time at all. Absolutely incredible looking at that kind of example. And if we look at kind of the interactions between dogs and humans, we see that dogs make eye contact with humans a lot. Wolves, not so much. And when dogs make eye contact with their owners, and their owners make eye contact with the dogs, we see that in both animals, oxytocin levels go up and are expressed. Oxytocin is the same chemical that relates to a mother bonding to her infant, during nursing predominantly. But it's kind of that mother-child bond that chemical produces. And so when people sit here and go around and treat their dogs like their children, they're not just doing that figuratively. They're doing that literally. Okay? Because in your brain, it's using the same types of chemicals in the exact same type of way to produce that bond. So when it comes to a person and their dog as a pet, man, don't mess with them. Okay? They will defend that dog as if it is a child of their own. Right? So just something to keep in mind there. Anyway, so I just think it's kind of cool looking at the evolution of dogs here, seeing that they can do all these different things, understand pointing, they can even understand facial expressions. They've been with humans for thousands of years here, undergoing parallel evolution with them. Not only because we're exposed to the same types of environments, but because our brains are reworking themselves in a similar type of way. So we're kind of convergent evolution. We're converging on a single point, so to speak, because we're in the same types of environments and exposed to the same types of stimuli. And we can see that even when we look at some of these different genetic mechanisms in humans and in dogs. It's kind of cool. Another thing I'd kind of like to briefly mention, we can look at the ability of dogs to digest starch very briefly, and see that modern dogs, the domestic dog, has 29 copies of this gene that helps them digest starch. So we had dogs, we domesticated them from wild dogs, from wild wolves, and then we started settling down and having farms, domesticating crops. At that point, we started having other food sources that our pet dogs could start utilizing. So we needed to kind of get in there and be able to give our dogs some sort of nutrition and hope that they're able to take it. So dogs started cleaning up not only the meat scraps, but they also started cleaning up some of the food scraps, some of the carbohydrate scraps. So they have gotten to a point where they have over 10 times the numbers of this amylase gene that helps them digest starch than wolves do. Okay, wolves only have about 2 or 3 copies. Dogs have about 29 copies of this gene to help them digest that starch. So, absolutely crazy. And we can track that back to about 12,000 years ago or so, when we started domesticating crops and staying in one place. So, pretty cool. I thought it was kind of neat to kind of look at some of these things, just because, like I said, I think it's a pretty open and shut case that dogs did not need aliens to evolve. Okay, they were perfectly able to evolve on their own and with artificial selection by humans, and we can track that through the genetics, through these fossil records, and through mutation rates to back calculate all these different things. And we can see this gradual progression into the modern dog. So, no need for aliens. But thank you so much for joining me on today's episode of Based on Facts. If you would like to find any of our episodes online, you can look us up on Facebook or YouTube just by typing Based on Facts in the search bar. So, thank you so much for joining me, and have a great one.